Hi guys, so in this video we're also still looking at trigonometric integrals, but in this case we'll be looking at integration of sine of sine to the power of m of f of x times cos to the power of m of f of x. Now, in 1.3 of our study guide, it says that when either m or n is an odd number, we split the odd power and use the following identity. So they're saying that, okay, let's look at that statement clearly. So they say when either m or odd, m or n, meaning this one or this one is odd, right? The odd one, what you're going to do is you're going to split the odd and use the identity sine of x, sine squared x plus cos squared x is equals to 1. So let's look at the example. In example 6, so example 6, they want us to solve the integral sine cube x times cos squared x dx. Now, they said that before we solve this, let's go back to the statement. They say when either m or n is odd number, we split the odd power and use the identity, this identity, meaning that one of them has an odd power. So meaning that you can either had sine to the power of 3x times cos squared x, or you can have a chance where you have sine to the power of let me write it like this, sine to the power of mx times cos to the power of n dx. So this one can be odd, or this one can be odd, right? So meaning that this case also applies if you're integrating sine squared x times cos to the power of 3x dx. So the statement says when either m or n is an odd number, we split the odd power and use the identity. Meaning that here we'll split sine to the power of 3 because why? Sine to the power of 3x because that is the odd one. And then we'll use this identity here. In here, on this one over here, we'll split this one here because the cos is odd. And then go back and use this identity over there. So now in example 6, this is example 6, this question here. So therefore it means that we follow that statement that says we split the odd power and use the identity. So the odd power will be what? Will be sine to the power of 3x. Now, when one can ask, how do we split? Exactly the same way how we were splitting when we had the odd power of something, like the odd power of cos or the odd power of sine. Remember when we had, for example, the odd power of cos to the power of x dx, right? We know that 5 is an odd number. So how did we split that? We said that we first write the odd part, right? We split it into an even part and an odd part, right? Now the odd part will have to the power of 1. So cos x to the power of 1. And then the even part will be whatever remains, such that when you multiply with this one, they give you cos to the power of 5. And we know that's cos to the power of 4x dx. So that's what they mean by splitting. Okay, so let me erase here so that we can then continue with example 6. So now let's continue. So we look at this and we see that sine is odd, so we split the odd part. So let's do that. So then this is equals to the integral of, remember when we split, we're splitting this part. So when we split, we have the odd part, which is to the power of 1 times the even part. Now the even part, we know that the odd part is to the power of 1, meaning that the even part has to be sine squared x, so that we multiply sine squared x times sine x, then they give us sine to the power of 3x. So meaning that this will be sine squared x times this cos squared x. Don't forget when you're splitting dx. Now they say use the identity this. Now where do you use the identity? You use when you have split it. Where you split. Don't make a mistake and use it here. on cos squared, because cos squared is not part of the splitting. This is where you split the odd power, right? So now we know that if we have sine squared x times sine x, and we have split the odd power of sine, it means that this identity that we're going to use becomes sine squared x is equals to 1 minus cos squared x. We just took cos to the other side. So then let's use this one and apply it there. So now this will be equals to integral of 1 minus cos squared x, right? This part, we have replaced it with this identity there. Let me just, this identity there. Then we have the sine, so that's times sine of x times cos squared of x dx. Okay, so now let's multiply this one with this entire term over here. So this is integral of, we then have sine x times cos squared x, right? Then we multiply this term with this whole term there. This becomes minus cos squared x times sine of x times cos squared x dx. Okay, so now let's simplify. This is the integral of sine of x times cos squared x minus, what's this? So this is cos squared x times cos squared x. This is minus cos to the power of 4x times sine of x dx. So then we can take the integral of the individual term, meaning we can write it as the integral of sine of x times cos squared of x dx minus the integral of cos to the power of 4x times sine of x dx. Now, if you notice, right, especially when we're looking at those trigonometric integrals, there's a formula that we have been using, and make sure that it stays in your heart, so you know it, like the way you know at the back of your hand and your hand basically. So that formula is the integral of, they say that if you have a function f of x to the power of n times the derivative of f of x, the dx is equals to f of x to the power of n plus 1 over n plus 1 plus c. So this formula, we've been using it especially a lot. If you look at all the examples for trigonometric integrals, we have been using it a lot, right? So meaning that you have to know it, especially when you're going to do trigonometric integrals, right? So now let's go back to our question. You see here, our f of x here is cos, right? And our n is nd. Okay, sharp. It means that the derivative, what is the derivative in this case? The derivative of, if we take f of x, right, is equals to f of x is what here? On the first term, okay? Cos. So here, f of x is cos, right? So that's cos of x, and we know that our n is 2. Right now, the derivative of f of x is equals to, we know when you differentiate cos, we actually get minus sine of x, right? So now, they want us to, so if we're going to substitute into this formula, so it will look like this. It will be what? The function cos of x to the power of n, in this case, our n is 2, times the derivative, which is negative sine of x dx. This will be equals to. Now, can we use this formula here? Can we write it, what's on the right-hand side? No, we cannot write it for this particular problem, for our problem. Reason being, if you look at sine doesn't have a negative in the pink part. Do you see this part here where we have to solve? Sine doesn't have a negative. And same applies if you look at the second term here. If our f of x in this case is what? Our f of x is cos x as well. It's almost similar to our first term here. So meaning that the derivative will be negative sine and not positive sine, right? So for us to be able to use this formula over here. So that's not a train smash, because what we're looking for, whatever is missing, for us to use this formula that I've highlighted in yellow and that I'm erasing currently and that I want to fix here, and that I'm struggling to fix currently. This formula, okay, let me rewrite that formula there. So we're saying it's not a train smash because for us to use this formula, we just need a negative next to sign. And if we have a negative next to sign, voila, then we can be able to use the what? The formula. That's what they're saying. So the integral of, let me rewrite it, of f of x to the power of n times the derivative of f of x dx. This will be equals to the f of x to the power of n, or n plus 1 over n plus 1 plus c. So, meaning that for both these terms, right, we need a negative because it says the function to the power, which is the function cos to the power of 4 times the derivative of cos. And we know the derivative of cos is not positive sign, but negative sign. So it's not a train smash because we need a negative, and we can introduce a negative in the integral because it's a constant. So we can introduce a -1 so that we get a negative sign like this, and be able to apply this formula like that. So let me erase here so that we go then and introduce the negative sign. So because we're looking at for the negative sign, let's do that. So then this is equals to, okay, this is equals to, we are allowed to say -1 times -1 times sine of x cos squared x dx minus integral of -1 times -1, which is positive. So cos to the power 4x times sine of x dx, right? Now, because we need one -1, so meaning we can take the other one out of the integral sign. We are allowed to do that because remember that it's a constant. -1 is a constant, so you can take out a constant out of the integral sign, right? So this will -1 integral. So we have -1 times sine of x times cos squared x dx minus okay, here we have to also take out the -1. So it's -1 integral of -1 cos to the power of 4x times sine of x dx. So then this becomes negative integral of -1 times this whole term. So this becomes negative sine of x times cos to the power to squared x dx. So this one, negative, this negative here times this negative, it becomes positive. Okay, I need to erase. I don't know why I said equals to. So negative times positive, negative times negative becomes positive. So this is the integral. We can then write as sine of x times cos 4x dx. Now one can say, why did I swap position? Remember, a times b is the same as b times a. So I didn't do anything illegal in mathematics here by just swapping the position. Okay, so now this is equals to, now we have negative, okay, before I go there, now let's see, because we want to apply this formula here. This is the integral of f of x to the power of n times f of prime of x dx is equals to f of x n plus 1 over n plus 1 plus c. If we look at this, we have a function which is f of x, right? In this case, our f of x. In this case, our f of x is cos x, and the derivative of cos x times the derivative of cos x, which is negative sine x. So we can apply this formula. So meaning that this will be equals to negative cos of x to the power of 2 plus 1 over 2 plus 1, right? Now, same applies to this one. So this will be plus, the function is cos, so cos of x, what is n? Our n is 4 plus 1 over 4 plus 1, the derivative, this derivative is this one. So we are now on the safe side. So this is equal plus c. So let's simplify. This becomes minus cos to the power of 3x over 3 plus cos to the power of 5x over 5 plus c. You can also write it like this if you want. You can write it as this is equals to, sorry about that, this is equals to -1 over 3 cos of 3x plus 1 over 5 cos to the power of 5x plus c. Therefore, we have solved the integral sine to the power of 3x times cos squared x dx, which is then equals to minus 1 over 3 cos to the power of 3x plus 1 over 5 cos to the power of 5x plus c. Just to recap, we looked at our problem and we see that it's the product of a sine function and a cos function. Now we then say, okay, fine. When either m or n is odd, meaning that when one of them is odd, when one of the powers, whether it's the power of cos or whether the power of sine is odd, we then split the odd power and use the identity sine squared x plus cos squared x. So in this case, we saw that, okay, fine, the odd power is this one here. Then remember when we were splitting cosine, the odd power of this, you use the identity sine squared x plus cos squared x, right, is equals to 1. Then you split it into an even and odd part. Once you split to an even and odd part, you had a term that had sine squared x. Then you replace it with 1 minus, okay, I don't know why the pen is no longer writing. Then you replace it with 1. Sorry about that, guys. Then you replace it 1 minus cos squared x. So here we do the same. You take the odd one and then you split it and then you use that identity there. So if cos was the odd one in this case, then you are going to use cos squared x is equal to 1 minus sine squared x. If cos was odd, that is, let's say if it was like this was 2 and this was 3, then you were going to use this identity here because you were going to then split what? Cos to the power of 3x. Now, in our case, we split it only cos squared and we use this identity because we split it cos to the power of 3x. Okay, thank you guys. Bye.